Hi all, welcome to video 12 of the langchain genai using langchain and databricks playlist. In this video, we will be learning about basics of semantic search and we will be learning about cosine similarity. So in last video, we saw how to work with embedding models for a single user query and for the document, how to find the embeddings for a single user query and how to find the embeddings for the document, right? Now what we will do, now we will create a document similarity application. Okay, the design is we have, let's say, 5 documents, the that are whatever I'm showing you on the screen, right? We have, let's say, 5 documents, and we will be having the user asking the questions, right, based on these 5 documents. Now we want to find out from these 5 documents which is the one document which is, very close to the question, right? We will create, so the steps would be, I think I gave small introduction. I don't know if I have given in last video, but that is fine. Steps would be, the first step, create embeddings for the document, right? Creates embeddings for the document. Second, create embedding for the user query, right? Create embedding for the user query. Next would be, let's say, compare the document embeddings and user query embedding. And fourth would be, let's say, select the document which is highly similar to the user query, on high level. These will be the steps we'll be following, right? And to find the basically similarity, we'll be using cosine similarity, right? More the similarity score, that would be our answers, right? And the one thing you have to understand, all the parameters that are going to be passed inside cosine similarity function should be a to-do list, right? So what we'll do, we'll get started. Okay, now what we'll do, we'll first run the installations, right? First run the installations, let them run. Okay, installations. Now we will start writing the code until the installations are running. That is fine. First we will import our model from databricks underscore langchain, import databricks embeddings, right? Databricks embeddings, because we want to work with embeddings, right? Next is we have to import cosine similarity, right? So what we have to do, from sklearn.metrics.pairwise, okay, import cosine similarity, okay. Now what I'll do, I'll just create an embedding model to use. Embedding model to use equals to Databricks embeddings, okay, and endpoint is the same we have used in last video, Databricks BGE large en, right? Same one, okay. Now I'll just copy the documents that I have here, right? Let's say these are my resulting documents, okay. These 5 documents I'll be having, okay. So I'm copying these documents here, okay. The next thing, I'll just enter the user query. What is the user query? User query is, user is asking which country, right? Which country is known for best wildlife? Which country is known for best wildlife? So if we go that way, India is diverse country known for rich culture and fast growing economy. US is global superpower, innovation, technology, concerns. Japan is island for technology and traditional culture. Germany, is for engineering excellence and strong economy. Brazil is for Amazon rainforest and football culture. Australia is country for unique wildlife and high quality of life. So ideally, the answer should be, you know, Australia, right? So what we will do? The first step we will create is user query embedding, right? Or let's create documents embeddings equals to embedding model to use embedding model to use dot embed documents embed documents, right? And I'll be entering the resulting documents here, result documents. I have to create the embeddings for all these 5 documents. This we have seen in last video, how to find the embeddings for the document, right? And now what I'll do, I'll maybe find the embedding for user query embedding equal to embedding model to use dot embed query. I'll use embed query here because this is one user query. I need one embedding here, right? Fine. Both the embeddings, like I have created the variables to find the embedding of the document and also the embedding of the user query, right? Now what I'll do, I'll find the similarity scores. So similarity score of this user query, embedding of this user query with all these embeddings, right? Which is higher, right? So what I'll do, cosine similarity I'll use. Okay. What I'll do, first I will enter the user query embedding, right? The user query embedding. Okay. And the next is documents embedding, right? Documents embedding is already a to-do list, right? To-do list. Let me show that here where, see, document embedding, right? It's already a to-do list. Where is that? Embedding generated. This is again user query. Let me check. It might be here. Yes. See, it is already to-do list, right? What I have done, I have just converted this user query embedding to a to-do list. That's all, right? What I'll do, I'll now print the similarity scores, right? Let's see how they look like. Let's run this. Okay. No module name Databricks. Oh, it is Lang. Fine. Databricks langchain. Okay. Fine. What it will do? It will first create the embeddings of the documents, then user query embedding, and then it will find the similarity score. So from similarity score, you can see the highest similarity score is 0.74, which is for Australia, right? Now we will understand how to extract our answer from these similarity scores, right? So what I'll do, first thing, there are list inside list. I'll first get the 0th element of the outside list, right? So if I get the 0th element, it will give me only one list, right? Basics of Python. Hope you are aware, right? Now what we will have to do is, now this last one, right? All these are the elements of this Python list, right? So my fifth element, this would be 0th element, first element, second element, third element, fourth element, and fifth element. My fifth element, I want to match that, right? The highest one is my fifth element. So that index I want to capture, index number 5, right? And I want to search my result document with that index, right? So my fifth index of my result document is this one, right? Now how I would achieve this? Now similarity scores, the 0th element we have already captured. What I have to do is, I have to use list enumerate, right? And the similarity scores, 0th element of the similarity score. Now if you see, it has assigned the indexes, 0th index to this one, first index to this one, second, third, fourth, and fifth, right? Now, what I have to do, I have to now sort. This is the items in this list, right? I want to sort this list based on the second element of my this tuple, right? Second element of my this tuple. How I will do that? Okay, what I'll do, I'll just print would be the common, right? What I have to do, sorted. I want to sort the list, right? I want to sort this one. Okay, let me just copy and paste this. Okay, I want to sort this one. Okay, key equals to lambda x. Okay, x of 1, because I want to sort based on first. This is 0th element, this is first element, right? I want to sort based on x of 1. Okay, and how, let's say, descending order, reverse equals to false, reverse equals to false, right? Let me run this, right? So what I have done, I have sorted this list, whatever list I have. Okay, this full list, right? This full list I have sorted based on the um, second element, right? This element. Okay, in descending order. Okay, so highest we should come at the start. Just a second. Reverse equals to false. It has sorted based on ascending order. Okay, ascending order, that is fine. Okay, reverse false. If I put reverse true, right, that would be descending. Reverse equals to false. Okay, it has sorted this based on ascending order. Okay, now the thing is very simple. Now what I have to do, I just have to get the last element, right? Last element from this list, which is this one, right? Fifth one having highest similarity score. So -1 is used to fetch the last element of the list. Basics of Python, I hope you are aware, right? To fetch the first element. Okay, what else I can do is, let me show you, reverse equals to true. Okay, and I would be fetching the 0th element. Okay, result is going to be one and the same, whatever it is, result is going to be one and the same. Okay, now let me store both of these in some variable. Okay, so what I'll do, let's say match index equals match index. Okay, and match score, right, equals to this full thing sorted, right? Match index equals to this one. Okay, fine. And what I'll do, I'll print the match index. It should be 5, right? 5. Now my job is very simple. Matched record equals to, okay, my result documents, my result documents, okay, my result documents and the match index, right? The match index, right? And if I print the matched the record, it would be the Australia one, right? So look, let it run. I don't know why it is waiting. Let it run. Might be taking the compute from the serverless, right? So this is how basically we work with, similarity search. Okay, I'll just explain from the start what we have done. We have done the imports, right? I have imported Databricks embedding, I have imported cosine similarity, I have created a model, right? A variable for model to use. Then I have this list of documents, right? Practically you will be having list of documents like PDF or something stored, right? That you have to convert to the embedding, right? Then there is user query which you will have to convert to embedding. Okay, and then what you will do, you will find a cosine similarity, right? Similarity scores of, I have, let's say, 6 vectors, right? 6 result, 6 result vectors, right? And one user query vector. One user query vector. What I want to find out is which one vector is there from these 6 result vectors which are near, right, which are more similar to this one user query vector, right? And that I have found out. What I have done, I have sorted this list, right, through enumerate. What I have done, I have assigned the indexes. Okay, I have assigned the indexes to this list, right? Then I have sorted this list based in ascending order. We can sort it based on descending order also. If it is ascending order, I have taken the last element of the list, right? And I have just whatever is the last element, I have taken the match index for that okay element, and I have just found out my result, right? In practical world also, in projects also, this is how you find out, you find, right, the similarity. Okay, you either find the distance or you find the similarity score, right? In case of rag applications, there is something called vector store. Okay, and vector store has capability to retrieve the highly matching documents, right? So vectors, for example, there are 6 result vectors and you are asking vector store for, let's say, give me two highly matching, retrieve me two highly matching result documents based on user query. Vector store will do it for you, right? So you can, I mean, that we will learn in upcoming videos, but this is the basics, right? If you start developing rag application now also, right? The one, I think, example I gave you, I have my pyspark series where I have 62 sessions recorded, right? 62 sessions are there, and you want to, do let's say some similarity search application, right? You want to find out top 3 results where when otherwise concepts are discussed, right? In that case, okay, you would be able to develop that rag application, right? Fine, that's all. In this video, I wanted to give you the basic understanding, right? How the similarity search works, right? How the basic rag applications are developed, right? And I think that we have covered to, in much details, right? Definitely you need basics of Python here, and I hope all of us are aware at least the basics of Python. What are tuples in Python? What are lists in Python? How to fetch the, first element of Python list, last element of Python list, and all these things. Fine, that's all from me. um, I will see you in next video. I hope you are enjoying. Thank you so much for all your support, and I'll see you in the next video. Thank you.